Welcome to this webinar on SAFI Telecom, a structural analysis and design software for steel telecommunication structures, including lattice towers, monopoles, and guide masts. The software is built around a modern ribbon-based interface that streamlines navigation and enhances productivity. SAFI Telecom is fully compliant with the latest North American standards, including current editions of TIA-222 and CSA S37 standards. In this webinar, we'll provide an overview of SAFI Telecom's main features, showcasing the powerful generation tools that allow users to build telecommunication tower models quickly and efficiently. Let's begin with an overview of lattice towers and how they are modeled in SAFI Telecom. For lattice towers, the model is built using what are called segments. Each segment controls the width and height of that portion of the tower. A fixed slope option is also available, which automatically determines the width at each level, eliminating the need to specify it manually for every segment. For each segment, a leg section can be assigned from the built-in section library. The library is extensive, covering angles, round members, and much more, with no limitations on the section types that can be used in the model. Standard libraries are available for US and Canada, as well as other countries. For angle sections, the software allows to design connection, including splices, single shear, and double shear connections. Connections are defined using what is called a connection schema, which is assigned at each member end. Two types of connection schemas are available, one for leg members and one for diagonals, referred to as direct connections. Within the connection schema, users can assign bolts to the connection from the built-in bolt library, or a custom bolt can also be defined. The configuration of bolts, bolt spacing, and edge distances are all specified here, and these parameters are used to calculate the relevant limit states for the connection, including block shear, bearing shear, and net area tension. Once a connection schema is created, it is assigned to the member, and users can specify the number of bolts per flange. The next step is to define what is called the tower face, which refers to all the panels that will be assigned to the tower. For most telecommunication towers, the same face is typically applied to all 3 or 4 sides of the tower. However, if your project requires different panel layouts on each side, the software fully supports that as well, giving you complete flexibility for any tower configuration. Using the face identification command, a specific face can be assigned to each side of the tower. If all sides are identical, the same face can simply be assigned to all of them. To build a tower face, a series of panels is added in sequence. Panel type and name can be specified, and an extensive panel library is available to choose from. If a required panel does not exist in the library, the panel editor allows panels to be created or modified, with full control over hinges, bolts, and sections. Custom panels can then be saved to a personal library for reuse in future models. The process is straightforward: select the panel, specify the height, and set the number of repetitions if needed. Sections are then assigned to each panel. The number of sections required will vary depending on the complexity of the panel. Connections follow the same principle we saw earlier. A connection schema is assigned to each diagonal end of the panel, along with the corresponding number of bolts. Once all panels and settings are defined, a preview of the tower segments is displayed. Users then click the Generate button, and SAFI Telecom automatically builds the complete tower model. Telecommunication towers typically include horizontal bracing. In SAFI Telecom, horizontal bracing is defined using diaphragms. To add a diaphragm, the height is specified and a frame prototype is assigned to it. The frame prototype follows the same approach as column panels. A dedicated library of horizontal bracing panels is available, and a panel can be selected directly from there. Sections and connections are assigned in the same way as for column panels. Once the frame prototype is complete, it is assigned to the diaphragm. Different diaphragms can then be created at different elevations throughout the tower. For guide towers, a dedicated menu is available to define the guy wires. Here in this guide tower model, there are 3 elevations of guys. For each elevation, a separate tab is created where the details are specified: the elevation, the radius, the anchor elevation, and how the guys are connected to the tower. Several guy mount types are supported, and for each type, the sections of the connecting members and their connections can be specified and designed accordingly. The initial tension of the guys is defined in a dedicated section. Cable sections are assigned from a built-in cable library, with the option to create and assign custom cables as well. The initial tension is expressed as a percentage of the cable's breaking strength. The force coefficient used for cables can also be overridden directly from this menu. Once the model is generated, full editing control is retained. For example, the tension of any individual cable can be adjusted manually, and all parameters related to nonlinear catenary cables are fully accessible. Members can also be added or modified, including their attributes, at any point after generation. In short, the generator automates the initial tower model, but complete flexibility remains to add user-defined members, loads, and any other customizations as needed. The next step is to define the loads on the tower, both discrete and linear loads. Discrete loads are handled through the antenna definition command, which automatically generates antenna loads on the structure. SAFI Telecom supports several antenna types. Paraboloid and grid antennas follow the TIA-222 NX formula, a standardized method that automatically calculates wind loads and moments directly from the code. Flat, round, cylindrical, and hexagonal antennas are based on the CSA S37 and TIA-222 standards. Simply input the dimensions, and the software automatically calculates the projected area, force coefficient, and ICE load. And finally, generic antennas give you full manual control, allowing you to define all parameters yourself, including projected area, weight, ICE conditions, and force coefficient. This is ideal for custom or non-standard antenna configurations. These options make it straightforward to attach any discrete load to the tower. The antenna properties are specified, along with how it is mounted to the tower, including the face, elevation, offset, and angle. Linear attachments, such as feed lines and ladders, follow a similar approach. For feed lines, the properties are specified including the number of wires, diameter, projected area, distributed linear weight, and ICE conditions. Cluster configurations are also supported. Wires can be treated individually, or grouped as rectangular or circular clusters. A built-in feedline library is also available. All of these inputs can be managed either through the menus shown, or directly in tables. Tables in SAFI Telecom are a powerful feature. Values can be edited, copied across rows, and are fully compatible with Excel. Data can be copied from the table into Excel and pasted back seamlessly, including headers. This makes it easy to prepare or modify data externally and import it back into the model. Once all discrete and linear attachments are defined, they can be visualized directly in the model. We can see here linear attachments and antenna loads are both displayed on the tower. Display options provide flexibility in how elements are visualized. The next step is load generation. A dedicated wizard is available to create basic loads, and load combinations, where both CSA S37 and TIA-222 loading methods are available. For the CSA S37 standard, users can define and generate the dead load, as well as the thermal load when applicable. This section also allows users to specify the parameters related to wind and ICE loading, tower type and tower shape, with full control over the input parameters. The software supports the calculation of QH wind pressure using both methods provided in S3724. Users can choose between the option that applies the CE factor, or the option based on the Environment Canada equation. For each method, the relevant parameters can be customized by the user. The software also includes a database of regional weather data. From there, users can select the appropriate wind pressures for both design and service loads, along with the ICE thickness values. In addition, users can define the wind directions, which determines how many wind load cases will be generated. If a load pattern is required, this option can also be activated, allowing users to specify different heights. The software will then automatically generate additional load combinations based on the selected load pattern. Once all inputs are defined, the load generation wizard automatically produces the load combinations. Two types are generated for lattice towers: ultimate limit state combinations, used for limit state checks, and service limit state combinations, used for deflection verification. After running the analysis, results can be displayed graphically. Filters allow specific results or load combinations to be isolated, and an animation option is available to visualize how the tower deforms under load. The deformation scale can be adjusted as needed. For design limit state results, different limit states can be displayed individually, including compression, tension, and connections. By default, only tension, compression, and connection results are checked. However, SAFI Telecom also provides the option to verify additional limit states such as bending, shear, and torsion. When the CSA S37 standard is selected, checks are performed in accordance with CSA S16, and when TIA-222 is selected, the design standard used is AISC 360. This is particularly useful for any section type that is not an angle or HSS, as those sections will be fully designed according to the alternative design code. Additional tower results are available as well, including tension and compression diagrams broken down by member type, legs, diagonals, and horizontals. That covers the key features for lattice towers. Moving on to monopole towers. The monopole generator follows a straightforward approach. Segments are defined by specifying the pole diameter, height, and number of sides. Circular, square, and polygonal sections are supported, ranging from 6 to 24 sides. Fatigue design is also available for monopoles. Fatigue threshold stresses can be specified for different connection types, and for each segment, the type of connection at the segment end is defined accordingly. For example, a slip splice connection is assigned to a given segment and designed for fatigue using its corresponding threshold stress. Base plate design is also included. Anchor rod parameters are specified through a dedicated menu, and bolt patterns can be generated using either a uniform distribution or a pattern distribution. The layout updates interactively as parameters are adjusted. Two base plate calculation methods are supported, the AISC 48 bent line method and the TIA-222 yield method. For load generation, monopoles include the option to generate fatigue loads in addition to standard loads. Both wind gust and vortex shedding are supported. A built-in vortex shedding calculator is available, using the same equations as CSA S37, allowing users to quickly determine the vortex shedding wind force based on their model parameters. SAFI Telecom includes flexible and customizable reporting tools to simplify project deliverables. Templates are provided for lattice towers and monopoles, both a condensed version and a more extensive version, with the option to build fully custom reports as well. Reports can be tailored by adjusting table layouts, reordering content, and applying filters by load combination, member group, or member type. Custom layouts can be saved and reused in future projects. All reports can be exported directly to Microsoft Word or Excel for a smooth and efficient workflow. We've now completed this webinar covering an overview of SAFI Telecom Software. Ready to get started? Contact our team or visit our website for more information.